right, two-way frequency tables. When there are two categorical variables, data can be organized in a two-way table, okay? What that means is, if I'm talking about, are you a 9th or 10th grader, and are you a boy or a girl? Okay, there's two things that have to be occurring. The categories are labeled at the top and the left side of the two-way tables. So male, female, SUV, or sports car, okay? Two-way tables explains the counts, meaning like the tally marks. So like if you asked people a question, it just tells me who answered, how many people answered what, okay? And then a two-way frequency table also shows the frequency or the count of each category, okay? So like in the first example, I know there are 60 males and 180 females. I know 84 sports cars and 156 SUVs, all right? So the row totals are on the right. That's the 60, the 180, and then 240 is the total. How many people did you ask in all? And the column totals are at the bottom, all right? So these tell me how many total people did sports cars. So 84 people chose sports cars. I don't know nothing about if they're male or female, but I know 84 chose sports cars, okay? Then we have frequency, so joint frequency versus marginal frequency. Joint is on the inside, and marginal's on the sides, the totals, okay? Joint has to have two things, right? If I'm talking about the joint of something where that's where they connect, right? Then relative frequency is the percent for the whole table, okay? So if I'm talking about a relative frequency, I'm taking everything and dividing it by my total. So this is 100%. Okay, so what percentage of males answered the survey? 25%. Okay, what percentage of all the people asked preferred sports cars? 35%. Okay, so why is there a difference? What's the point? Okay, so the point is when I'm looking at just the numbers, it just kind of tells me like how many people responded to the survey, this many, okay? When I'm using frequency, it's going to ask about what percent of the surveys was female, okay? So we got to make sure we're understanding what the question is asking. So let's do an example. The students in a seaside school are to have extra swimming lessons if they can't swim. The table below gives information about the students in 7th, 8th, and 9th grade. All right, so first I need to fill up the tables. My totals come from 120 plus 60 is 180. So that's my total amount of kids in 7th grade. Okay, I have 168 and 179. So I have a total of 179 kids, but I know 168 of them can swim. So how many can't swim? So I can take 179 and subtract 168 and I get 11. Because 168 plus 11 gives me 179. Okay, so now how many total people can't swim? 60 plus 11 plus 3 is 74. All right, now I need to fill this box out. So my total is 460. So 460 minus 120, and then minus 168 gives me 172. So how many total 9th graders? 175. Now I need to figure out my total. So I can either add these three or add these two. They should equal the same. So 460 plus 74 is 534. 180 plus 179 plus 175 is also 534. Okay, so how many total people are in 7th, 8th, and 9th grade? 534 people. Okay, all right, how many students need swimming lessons? So if they can't swim, they need swimming lessons. So 74 people need swimming lessons. How many students are there in 8th grade? So I'm talking about just 8th grade. How many people are there in 8th grade? It's not 168, it's 179. It's a total. So you gotta read the question. What's it asking for? how many of the 7th graders, so I look at 7th grade, cannot swim. So I look at 7th grade and cannot swim is 60. How many students in 7th and 8th grade can swim? So I look at 7th and 8th and can. So 168 plus 120 is 288 because I add them together. How many students are there all together in grade 7th, 8th, and 9th? So how many total kids? 534. All right. Now it wants a relative frequency table. So this is where I'm going to take each box and divide it by my total. So 120 divided by 534, and we're going to round 0.22 or 22%. All right, 60 divided by 534 is 0.11. 180 divided by 534 is 33.33, 33%, which makes sense because 22% plus 11% is 33%. Okay, remember these are the same as percent. All right, so 168 divided by 534 is 0.31. 11 divided by 534 is 0.02. 179 divided by 534 is it's 335, so we're going to round to 3 actually, because 31 and 2 gives me 33. Okay, you might have to adjust one of these to make sure they add up right. 172 divided by 534 is 0.32. 3 divided by 534 is 0.01. So 175 divided by 534 should give me 33. So notice 33 plus 33 plus 33 is 0.99. I need this to be a 1. So I'm going to have to adjust. So I think it was 8th grade can swim. So let's do 168 again divided by 534. And that's 3146. That 6 can round the 4 to 5. So let's make this 32, which will make this 34. Okay. So then our total, 0.22 plus 32 plus 32, 6, 7, 8, 86 is what it should give me. So let's just check for 60 divided by 534 is 0.86. And then 0.11 plus 0.02 plus 0.01 should give me 0.14. So let's just make sure 74 divided by 534. I actually need to round that to 14. Right. All right. So what is the relative frequency of students who are in 8th grade and cannot swim? So 8th grade and cannot swim is 2%. What percentage of 9th grade students can swim? So this is where you have to read the question. What percent of 9th grade students can swim? So I just want to know what percentage of the 9th graders can swim. So I look at my total here, and I use those two numbers. So 172 divided by 175 is 92%, because I only am asking about 9th graders. I'm not asking about, of all the kids, what percentage are 9th graders and can swim. Okay, it's saying what percentage of 9th graders can swim. Gotta read that question carefully. What percentage of students can't swim? So I look at students that can't swim. So 74 divided by 534 is 14%. We already found that here. What percentage of students are 9th graders? 33%.